This is a final episode where we quickly implement some of the bonus features I showed in the previews. We will improve visuals and clean up our code. I will start by quickly changing background images just to keep things interesting. You can download the forest background layers in the video description, and I just replaced them in the assets folder, overriding the city images. I backed the old images up somewhere else on my computer. You can also go to background.js and adjust speeds of individual layers. Sometimes different background art looks better when speed modifiers on the background layers are adjusted. I also changed ground margin on line 17 in main.js to better fit this new forest environment. Since we are changing visuals, let's also change the font to something nicer. You can go to Google Fonts and choose any font from there. It will all work and it's very easy to implement. Let me show you with Creepster, because this is a Halloween themed game. We are in a scary dark forest escaping from creatures of the dark. When you choose your font, click Select this style. Now I click up here and it will give us everything we need to use this font on the web, in our web browser game. I copy this link tag. You can also select multiple fonts and they will be automatically added to the same tag. I will use just one font for now. I copy the link tag and I paste it up here in index.html. Notice I put it before my custom style CSS file because I want the font to be available when that file loads. Then I just take this CSS rule and I apply it to canvas element. Now I can use this font all over my project and Canvas will draw it. I will use it in UI.js for score, timer and game over messages by replacing Helvetica with Creepster here. I think this looks much better and you can choose from so many different Google fonts to fit the art style of your game. I have other favorites on here, for example a font called Bangers for a really cool comic book art style. I want the player to have a limited number of lives and I want those lives to be displayed on screen. Each life will be represented by a small image of dog head. You can also use heart image or something completely different, it's up to you. If you want to use the same image as me, you can download it down below. As usual, I bring it into the project here in index.html first. Then I hide it with CSS. I will be drawing the lives here in UI.js, so in the constructor I bring the image into the project like this. I will call it, for example, this.lives image. Down here under timer we will draw player lives. I will call draw image and I pass it the image I want to draw. I want to draw it at coordinates 20, 95 and width and height will be 25 pixels. Nice, we are drawing it here. I create this.lives property on the main game object. Let's start with 5 lives. Back in UI.js I create a for loop that will run once for each life and it will draw an image that represents it. Now I'm just drawing 5 images on top of each other. I need to multiply horizontal x position times index from the for loop. Actually it will be the width of the image, so 25 pixels, times index plus left margin of 20 pixels. Perfect. Now, when I change the value here, it changes how many lives are drawn on screen. Maybe you want your game to be easy, you can give the player 15 lives to start with. I will go back to 5 lives. In player.js, in the area where we handle collisions, when the player collides with an enemy while not rolling or diving, this animation is played by setting state to state 6. We call that state hit, and at the same time I want to remove one life, so this.game.lives -. After we removed one life, we check if total lives are less or equal to 0, and if they are, we set game over to true. I tested by colliding with enemies on purpose. You can see that each time we collide, we lose 1 life per enemy, and when we lose the last life, we get game over screen. Perfect. I want score numbers to fly from enemies as we defeat them. This can also be used for other floating messages in our game. I create a new file called floatingmessages.js. I create a custom class I call, for example, floating message, and I export it. Constructor will expect value of the floating text, starting x and y position, and target x and y position. Text with this value will float from this position to this position, and then it will disappear. I convert these values to class properties as usual. I also create a property I call timer, just to set some simple time limit after which the messages disappear. We will need update and draw methods as usual. Update method will push horizontal x position by the difference between target position and the current position, making it slowly move towards the target. Same for the vertical y position, difference between vertical target and current vertical position. For each loop, timer will increase by 1. When timer is more than 100, we set marked for deletion to true. Draw method will take context as an argument. We set font to 20 pixels creepster. Fill style will be white, and fill text will draw value from line 3 at its current x and y coordinates. Now I show you an alternative to use in Canvas shadows. For score and timer, we are using Canvas shadow properties. Here we will achieve the same effect by drawing the same text twice. White first, then black on top of it, and we give it 2 pixels horizontal and 2 pixels vertical offset. We are exporting our new floating message class. I import it up here on line 3 in player.js. Inside check collision method, when we successfully hit an enemy and score increases, I want those score points to fly from that enemy towards our scoreboard. I say this.game.floatingMessages push, and I want to use floating message class to create one new floating message object. First, I need to go to main.js, and on the game class I create this floating messages array. It will be an empty array at first. Now I'm pushing a new floating message into it like this. I check here and I can see that class constructor expects text value, start in x and y coordinates, and target x and y coordinates. Value will be +1 because we get 1 score point. We could also make this value dynamic if every enemy type gives different amount of score points. Starting coordinates will be x and y of the enemy we just collided with, and target x and y will be, for example, the top left corner of canvas, so coordinates 0, 0. Inside update method on game class, the same way we cycle through all enemy object inside enemies array, we will also cycle through all floating message objects inside floating messages array. For each message, we will trigger its update method. I delete this splice to remove old messages because we will do it in a better way. I'll get to it in a minute. So for every floating message object, I call their associated update method. I copy this code block, and inside draw, I also call draw method on every message, and I pass it context. If I play the game, messages will be moving too fast, so there is no animation. I just see the bottom of the letters here. I need to go to update method, and I need to multiply both of these by 0.03. So I'm saying here, for each animation frame, increase the current vertical and horizontal position by 3% of the difference between the target position and the current position. This will make the text move towards its target position by 3% of the distance per animation frame, meaning it will start moving fast, and as the distance between current and target position gets shorter, so it's a smaller number, 3% of that value is less pixels, so it will travel slower and slower, giving us a nice ease out effect. You can see that the movement is faster at first, and it slows down as the letters float closer to target 0, 0 coordinates on canvas. I adjust the target coordinates. I want them to flow somewhere to the end of score line. Maybe these coordinates? Yeah, let's do 150 and 50. Right now, we are creating an ever-increasing floating messages array because we are not removing the old ones. I will use filter array method to do that. It's better than using splice for a reason I will explain in a minute. Built-in array filter method runs a provided callback function once per each element in the array. Array elements which do not pass the callback function test are skipped and are not included in the new array. So when I say this.floatingMessages.filter, and as a callback I say marked for deletion property on each object needs to be false, the new array will contain only elements that have marked for deletion set to false. Elements that are set to true will be excluded. At the same time, I am assigning this new filtered array to the original floating messages array, overriding it. So this simple line of code filters out all elements that have marked for deletion set to true. In the previous episode, I mentioned a bug where I noticed that ground enemies jump and wiggle horizontally even when they are supposed to be static. It's especially visible when comparing ground enemies against the ground texture, but it is actually happening with all enemies. It is because as I cycle through the array, I am removing enemies that collided with player or moved off screen using splice. Problem is that when I splice out and remove enemy from the array while I'm in the middle of cycling through that array, it changes index of all the following elements, in our case enemy objects. Because of that, their position is not calculated correctly for that loop and they jump around. Instead of splice, I will use filter method and I will only remove enemies that have marked for deletion properties set to true after we finished cycling through the entire array, so there are no problems with indexes and skipping positions. Basically, I will do the same thing for enemies I just did for floating messages. I will also do the same thing for particles like this. And finally, I also do it for collision animation objects. Now that's better, we fixed the bug, and I think this syntax is a bit cleaner as well. I just quickly console log all my object arrays. I put it inside add enemy, so it logs it only periodically, not for every animation frame. I play the game and I can see that all the arrays are being correctly filled with objects, and those objects are also being removed. Perfect. Player class doesn't have this.currentState property because I had to define it from inside game object here. That property belongs on player class, so I can define it here and initially I set it to null. This is just a cleanup, the code will still work the same. Let's tune the game difficulty to make it a bit more challenging. Max time will be 30,000 milliseconds or 30 seconds. In this time, the player needs to reach at least the minimum winning score of 40 to see the winning message. We can do other things. For example, every time player gets hit by an enemy and this animation is played, we can remove 5 points from the score as a penalty. You can tune your game however you want. You can make it easier or more difficult by adjusting these values. When the game is over after 30 seconds, I check if score is more than winning score, and if it is, we display winning message. Else, we display the losing message. Let's test it. I play it and I get hit over and over. My score is in minus values. I get game over and losing message from line 35 is displayed. Nice. I increase game width to 900 pixels. I will keep game height at 500 pixels because our background images are optimized for that size. We're not gonna go into aspect ratio calculation in this class. This time I will really try to play the game and let's see if our winning condition works. I need score over 40 in 30 seconds. It's actually pretty close. Yes, I played well. I got 55 score points and winning message is displayed. Awesome. We are done. Let me know in the comments if you coded all the way through and if you learned something new. I'll see you later.